back to Miss Now Speaks, and we're gonna do differentiation today, or also known as derivative. And derivative is a very important chapter in calculus. Okay, so basically I'm gonna cover two methods of derivative today. The very basic one, the very simple one, and also chain rule. So let's move on. Okay, so in today's lesson, we're gonna learn how to do derivative, as most of you have heard it, which is also very widely known as dy dx. So the d there actually stands for difference that comes from the word derivative. Okay, so how do you find dy dx of a particular function? You need to know the basic formula first to find dy dx, which most people call it, and let's assume that we actually have a very simple function which looks something like this. So the idea here is to do something with the power. Alright, so in order to do differentiation, therefore the differentiation dy dx will be, first step is to bring this power to the front here and multiply it with the coefficient of the function, whichever function that you have, and the coefficient that is in front of the function. Okay, upon bringing it down, you have to decrease the power by 1. Remember that? So decrease the power by 1, and therefore this is the final answer that you're going to have for your derivative. Okay, now let's try a few examples here. I'll give you a very simple function. Say y is equals to 8 to the power of 3. Now what is the differentiation? Using this formula that we have learned above, we know that we have to take the power down, right? So 3, bring it down to the 8. 3 multiplied by 8, what you have is 24, and 3 decreased by 1 gives you 2. Okay, simple, right? Alright, what about a second example where I give you a function or reciprocal function, if you still remember what is reciprocal function. Okay, and the power now is at the bottom, power 2 of x. Now the first step that you need to do is actually to make it not be reciprocal in order to simplify your future steps. Okay, of course you can do it in this method, as a fraction itself. If you have already gotten or do more exercises, okay, if you're used to it. So if I were you, I'm just gonna bring this up according to the index law, if you still remember the index law. Okay, otherwise please look back at the previous videos that I have posted. Okay, now you can see something very similar to the example that was given previously. So bring the power -2 to the front, multiply with 5 will give you -10, and then -2 will decrease by 1. Now don't forget, because it's a negative number, therefore it actually becomes -3 instead. Okay, what if I have a function that is in forms of square root, say square root of x? Same thing, you want to change it to a power, so square root of x is actually a power of half. So power of half, now let's do the derivative, so bring the power down, and half minus 1 will be -half. Okay, now I would like to introduce you the chain rule now. So what about the chain rule? Okay, the chain rule is very similar to the original method of differentiation. This is that you have to use it because you have functions that are given in higher powers and more complicated form. For example, you have something like this. Okay, of course you can actually opt to expand this using algebra expansion knowledge, but it's going to be a hassle because you have to actually open up 5 times of x plus 1. So using the chain rule, it's very similar again to the first method that we have learned. You bring the power down, and then you actually need to look at what is inside the brackets and also do the differentiation for what is inside the bracket. So differentiate x will actually give you 1. So I'm sorry that I forgot 5 minus 1 is 4. Therefore, your answer is just this. Okay, we can have a bit more complicated example. Say now I switch this to 2x power 3 minus 4n power 7. So what is the derivative? And we have to use the chain rule because this is a very complicated function, and therefore using the chain rule we bring the 7 down first, and you're gonna have this, don't forget the minus 1. Okay, and then don't forget to do what is inside the bracket. So doing what is inside the bracket using the first rule that you have learned. Okay, and I always like the idea of simplifying the single terms. So simplifying the single terms will give you 42x squared, and then this is the final answer. Okay, let's do a few more examples. So I have prepared a few more examples here. So now you have this example here, how you're going to do your dy dx. Similar, bring the power down and then recopy what is inside the bracket and the power minus 1, and do what is inside the bracket, that gives you 0. And again, simplify single terms. Okay, so simplify single terms, and there you go, you have this. Okay, we have a few more questions to go. So let's complete a few more questions. I hope you are doing it together with me, or at least have tried and compare your answers with mine. So you have this, and don't forget, because it's a negative power, so negative 3 minus 1 give you a negative 4. So many would have changed it to negative 2 instead. Okay, and then this is a bit more complicated. So yeah, because it's a bit more complicated, I can choose to leave it like that, or I could also just leave it in this method. And I'm sorry. So yeah, okay. And one last example. I'm sure this is really easy already. So what is the first thing that you need to do again? Bring the power down, power minus 1, and do what is inside the bracket. So if you don't want to write the 0, it's fine, because you're so used to it and you know differentiating a number, it gives you the 0. Alright, okay, so that's it for today. Stay tuned for my next video, because I'm going to show you how to do derivative using another two famous method, which is known as the product rule and the quotient rule. So till we meet again, for those of you who have not subscribed my channel, Miss Nell Speaks, make sure you click on the subscribe button so that you get notified of new video postings. See you again, and bye bye.